Alright, you guys, example 13 is just as exciting as example 11 and 12. The factoring part is a little bit more challenging, but other than that, it's the same thing. It'll be like deja vu. We're going to do the same thing that we just did in the previous two example problems. So if you're confident in your factoring skills and you're confident in finding all these nifty things, go ahead and try it on your own. Otherwise, follow along. So we start with our horizontal asymptote, which remember, it's all about the degree of the numerator and denominator. So let's start by labeling the degree of the numerator and our degree of denominator. Alright, so the highest exponent I see in the numerator is this 2 right here. So the degree of the numerator is 2. The degree of the denominator, what's the highest exponent we see? It's right there. It's a 2. Oh man, you guys, this time the degree of the numerator is the same thing as the degree of the denominator. So this time the degree of the numerator, which I'm going to abbreviate, degree of the numerator equals the degree of the denominator. So, what do we do when that happens? Remember, when the degree of the numerator equals the degree of the denominator, all you do to find the horizontal asymptote is to divide the leading coefficient of the numerator by the leading coefficient of the denominator, and then we will be done. So the leading coefficient of the numerator, we first identify the term with the highest exponent, which is this one. And then we take the coefficient, which is the number sitting in front. So the number sitting in front is my 2. So the leading coefficient of the numerator is 2. Same thing for the denominator. We identify the term with the highest exponent, which is this one. Alright, and the number sitting in front, there's secretly a 1 hiding out. So the leading coefficient is a 1. So I'm going to do 2 divided by 1, which is 2. So there will be a horizontal line that crosses the y-axis at 2 on our graph. Fun times, right? Alright, now in order to do our vertical asymptote and our zeros, we must factor first. Okay, so let's factor this one. We're going to have to factor both of them because we have above degree 1 in each of these. So we're going to be factoring both of these things. So we're going to factor the numerator, which is 2x squared minus 2, and the denominator, which is x squared minus 4. So let's think about this. Whenever we factor, what's always the first thing we try to factor first? You guys are so smart. It is the GCF. We always look for a GCF first. Okay, so in this one, what is something that is in both of our terms right here? What's something that I could divide into 2x squared and negative 2? You guys are so smart. It is 2. So first we're going to factor out a 2, which remember when we factor out the GCF, we divide each of these by the GCF, which is 2. So 2 divided by 2 will cancel out, so I'm left with x squared. And negative 2 divided by 2 will be a negative 1, so minus 1. Alright, but remember, we always ask ourselves, can we keep factoring? And we hope we can because we love to factor. So now I'm going to look at this right here, and I'm going to see if I can factor this. So I have 2 terms and I'm subtracting. And I have a quadratic, okay, which means I can square root that thing. So let's see, if we have 2 terms and we're subtracting, our options are a difference of cubes and a difference of squares, which a difference of cubes is not going to work because I cannot cube root a square. Okay, so guess what we're going to do? A difference of squares, which I'm going to abbreviate with the DOS. Okay, so for a difference of squares, okay, once we find our A and our C, okay, if we have 2 perfect squares that are subtracting, once we find the A and the C, we just add and subtract them, and then we're done. So let's find the A and the C. So the A, we square root the first term, which is an x squared, and the C, we square root the second term, but don't forget we ignore the negative. So I'm going to square root the 1. So the square root of x squared is x, and the square root of 1 is 1. 1 times 1 is 1. So this, in factored form, I just add these 2 and subtract these 2. Then we're done. So it's going to be x plus 1 times x minus 1. Yay, so our numerator is factored. Yay. And don't forget, oh, hold on. Don't forget about your bestie GCF right there. Everyone always forgets about him. Poor old GCF. So that is going to be our numerator. So our numerator is 2 times x plus 1 times x minus 1. Yay! Alright, so our denominator. Let's look. We look for a GCF, which, if we're looking here, I don't see anything that goes into x squared and 4. So if there's not a GCF, you just move on. So I have 2 terms and we're subtracting. So what kind of factoring technique can we use? Well, our options are a difference of squares and a difference of cubes, which a difference of cubes is going to fail because we cannot cube root a squared, and we can't cube root a 4. So by default, we have to do a difference of squares, which I'm going to abbreviate to DOS. Alright, which remember the rule, once we find the A and the C, we just add and subtract them, and then we're done. So my A, I'm going to square root my first term, which is an x squared, and I'm going to square root my second term, but ignore the negative, so we're going to square root the 4. So the square root of x squared is x, and the square root of 4 is 2. So my factored form for the denominator, we just add and subtract these. So we have x plus 2 and x minus 2. So yay, the denominator is factored now. Awesome. So our denominator is going to be x plus 2 times x minus 2. Alright, let's start finding these vertical asymptotes and zeros, and then we'll be done. Okay, so for the vertical asymptotes, we set every single factor equal to 0, and then we're done. Which factors, you guys, have to contain an x in them. Those are the only things that could possibly go to 0. Okay, so I'm going to set this x plus 2 and this x minus 2 equal to 0, and then I'm going to solve. Alright, which the way we move negative 2 to the other side is by adding that thing on both sides. Negative 2 plus 2 cancels and turns to 0. 0 plus 2 is 2. So we have one vertical line that crosses the x-axis at 2. And the other one, the way we bring positive 2 to the other side is by subtracting it on both sides. Which 2 minus 2 cancels and turns to 0. And 0 minus 2 is negative 2. So the other vertical line that hits the x-axis at negative 2 will be x equals negative 2. So we're going to have 2 vertical asymptotes this time. Holy hot dog, right? That's a lot. That's cool. We haven't experienced 2 asymptotes yet that are vertical, so that's pretty cool. Alright, and then the zeros will tell us where the graph will hit the x-axis. And we set every single factor in the numerator, which these are the things that contain x's in them, you guys. This 2 will never equal to 0. If I set 2 equal to 0, that doesn't work. Okay, so we're just going to ignore the 2 for now. So I'm going to set x plus 1 equal to 0, and I'm going to set x minus 1 equal to 0. And after that, we'll be done, you guys. So the way we bring positive 1 to the other side is by subtracting that thing on both sides. 1 minus 1 cancels and turns to 0. 0 minus 1 is negative 1. So we have x equals negative 1. Or the way we bring negative 1 to the other side is by adding that thing on both sides. Negative 1 plus 1 cancels and turns to 0. So we're left with x equals 0 plus 1 is 1. So this will cross the x-axis at negative 1 and 1. So we have a horizontal line at y equals 2. That's an asymptote. We have 2 vertical asymptotes at x equals 2 and x equals negative 2. And we have 2 zeros at negative 1 and 1. Whoa, whoa, whoa. That was pretty cool, you guys. And the graph, this is one of my favorite graphs. So when you go back to the Prezi, get way super excited because it's just going to blow your mind. It's going to be like, it's going to be so cool. So go ahead and go back to the Prezi and see what this epic graph will look like.